Hello everyone and welcome back to the channel. Have you ever wondered if the tightening torque you are using is actually correct? Too little torque and your joint can loosen during operation. Too much torque, you might permanently damage or even break the bolt before the machine is ever put into service. So the truth is that many engineers rely only on torque tables without understanding where those numbers come from. In this video, I will show you exactly how to determine the correct bolt preload pretension for different bolt sizes and strength classes, how to calculate the required tightening torque using one simple formula, and at the end I will give you a free Excel file that already contains all the preload and tightening torque values according to VDI 2230. So make sure you follow me step by step until the end. Let's get started. Before talking about torque, we first need to understand preload. When you tighten a bolt, you are not just turning a nut. You are stretching the bolt like a spring. So that stretch creates a clamping force between the connected part, which is like in this example here, like between these two plates. This clamping force is called the bolt preload or pretension. So almost every bolted joint is designed based on this preload because it's prevent joint separation, prevent self-loosening, reduce fatigue like loading, and improve stiffness. So one common misconception is that torque is what keeps part together. Actually, preload keeps part together. And that's why in ANSYS actually we use a bolt pretension on the beams or on the solid-like bolt when we are model it as a solid, just to get this like a clamping force. So torque is simply the method we use to generate preload, and this distinction is extremely important. So now let's look at the preload values. I already prepared for you an Excel file, as I said on the beginning of this video. And as you can see on the screen, on this table, we have a table containing bolt size, the stress area of each one of them, strength classes from 8.8, 10.9, and 12.9 for each one, and the recommended preload according to VDI 2230. So for example, as you can see, we have a bolt size from M4 until M39. And for each one of the strength class, we have the relevant maximum allowed preload pretension. These preload pretension, they are in kilonewton, so don't miss that. Notice something interesting. So even if the bolt diameter stay the same, increasing the strength class from 8.8 to 10.9 or even 12.9 allows a significantly higher preload. As you can see, with 8.8 we are allowed just 4.4 kilonewton. With higher strength class we are allowed with until 7.6 kilonewton. That's because higher strength bolts can withstand greater tensile stress before yielding. So this is exactly why selecting the proper bolt grade is just as important as selecting the correct diameter or bolt size. If you wanted to see more about the selecting the right bolt size and the strength class, you can see the previous video. I already mentioned that according to VDI 2230. Now comes the questions everyone asks. How do we convert preload into tightening torque? So fortunately, the engineering approximation is very simple. As you can see on the screen right there, we have this formula, which is the tightening torque is not more than the knot factor coefficient K multiplied by the preload pretension for the selected bolt size, and multiplied by the diameter of the bolt, the nominal diameter actually for the bolt. So now let's calculate one example together. As you can see, I already have prepared a table where you can use it as a calculator for you. So suppose we have M12 bolt, which has like a diameter, nominal bolt diameter of 12 millimeter, and that's like means 0.012 meter. And the bolt pretension like allowed according to VDI 2230 for M12 bolt, for example, with 10.9 Franks class. Let's go back to the table on the first tab, and for M12 10.9 we are allowed to use 63.2 kilonewton. So I'm gonna back to the table and I will write there 63,200 newton. We should like input like one another like parameter, which is like called the K parameter, which is the torque like coefficient, and that coefficient or not factor K depending on the surface conditions actually, and many other factors. And as you can see on the second tables, the K value is actually lies between some ranges depending on the conditions, which is could be like well lubricated, lightly like oiled, dry clean steel, or like with a zinc like coated. So in my situation, I'm gonna to use actually 0.2 for this parameter, which is like equivalent to dry clean steel. So based on this like selecting like parameters, I got like a value of around 151 Newton meter as a required tightening torque for the M12 bolt with a Franks class of 10.9. So remember that the torque coefficient depends heavily on lubrication, surface finish, coatings, and thread conditions. So in case like we have like a well lubricated conditions, so it might be our like K parameter 0.16 instead of 0.2, and depending on this factor, our tightening torque is now much less than the 151 Newton meter. So the same bolt can require noticeably like different tightening torque if the friction changes also. That's one reason why VDI 2230 emphasizes like friction so strongly. I'm gonna talk about it in detail later on the next videos. So here are a few practical tips that can save you from expensive mistakes. Tip number 1. So never use random torque values from the internet. Always verify the bolt grade, lubrication condition, and design requirements. Tip number 2. Torque alone does not guarantee the correct preload because friction can vary significantly. Tip number 3. For highly critical applications, engineers often use more accurate tightening method such as torque angle tightening, yield control tightening, or hydraulic tensioning, for example. So understanding these differences is what separates basic assembly from professional like engineering design. As I promised you on the beginning of this video, I have prepared for you a full Excel spreadsheet that contains the bolt sizes, Franks classes, thrust area, and recommended preload values, also the calculated tightening torque, and a ready-to-use table according to VDI 2230, which is actually on the third tab there. You can see the full spreadsheet for like many like bolt sizes, like with all the 3 Franks classes, and at each like frictional coefficient, which is they are like here between 0.08 until 0.24. To each one you can find the maximum allowed preload pretension and the equivalent tightening torque for these conditions. So this means you don't have to calculate everything from scratch every time. If you would like a copy of this file, simply write me on the comment below and I will send it to you. Like if you think preload at the end of bolt design, there is actually another critical step. So after determining the preload, we still need to verify whether the bolt is safe under the applied loads. In my next video, I will show you a complete hands-on example of calculating the safety against shearing of a bolt according to VDI 2230, and then we will verify the results using ANSYS. You will see the entire process from theory to simulation and learn how professional engineers validate bolted joints. So if you don't want to miss it, make sure you are subscribed. If you found this video useful, please give it a thumb up because it really helps that channel. Leave your questions in the comments. I read every one of them. And don't forget, if you want a free Excel file with all the preload and tightening torque values, simply mention that in the comment section. Thanks for watching, and I will see you in the next video.